Hi everybody, welcome to this video on inverse variation. Now let's just go over the example first, the first little bit of it to explain what inverse variation is. Okay, so for a fixed volume, the height of a cone varies inversely as the square of the radius of the base, right? So that looks really complicated, so let's deal with that in bits, okay? So inverse variation, what does that mean? That means that as one quantity is going up, the other one is coming down. We discussed in class today something that would be inversely proportional, would be like the value of a car and its age. So when a car's brand new, it's got a high value, and as it gets older, the value drops. So as the age of the car goes up, the value goes down. So that's inverse variation, okay? With this example, if you've got a cone that holds the same volume, if you make the top of the cone smaller, then the height's got to get longer. So as the radius of the base of the cone, the top of the cone, gets smaller, then if it's going to hold the same amount of liquid, the volume of it, the height has got to get longer, okay? We discussed this a little bit with one of the groups when we were doing the funnel challenge earlier on, okay, this week, but that's how that works, okay? So for a fixed volume, if the volume stays the same, then the height of a cone varies inversely as the square of the radius of the base. So at the same time, if the height of the cone gets smaller, then it's going to get wider at the top if the volume is going to stay the same. I think you can all kind of picture that in your mind's eye, okay? Right? So this bit about the square we'll come on to in a minute, but let's start off the question. So it says, when r is 5, h is 8, find the height of the cone with radius 2 centimetres. So we're going to start this off. What I want you to do is to copy this down just now. So pause me and copy this down. So we're going to have to move the board up and you'll not be able to see it in a little minute, okay? So if you just pause me just now and copy that. And then we'll move this up a little. Okay, so looking at the variation statement, so it says the height of a cone. And if we're saying that something varies inversely as, we do 1 over. Okay, so direct variation, remember, was just varies directly as r, but if it varies inversely as r, then we do 1 over. So this is inverse variation, so the 1 over the quantity, the variable, gives us inverse variation, okay? So using 1 over, inverse variation. If we don't use 1 over, it's direct variation. Remember we discussed that difference yesterday, okay? Now, so the height of a cone varies inversely as the square of the radius of the base. So that means it's going to be the square of this variable here. So it's the square of it. Okay, so r squared. We've introduced that now as well, right? So that's 2 new things, okay? So it's inverse variation. So we put 1 over that number, and we'll look at that in a bit more depth tomorrow, okay? And the square of the radius. So we're introducing as well, putting in square roots and squares and things into your formula. So this is a variation statement, okay? So remember, this symbol, the little fish, or the alpha, stands for varies as, okay? So varies inversely as, inverse because it's 1 over and r squared. Now I know that's quite really mathsy and it's kind of difficult to get your head around, but like, please bear with me with this, okay? So the next step, we get rid of the little fish and we introduce equals k, alright? So if we do that, then we have equals k times 1 over r squared. Now, what I want us to do here is, that's technically what we're going to do. Okay, but we can make that a little bit more simple by just multiplying these two fractions together. So remember, if we're multiplying k over 1 times 1 over r squared, then we're going to end up with h equals k over r squared. So remember, with this, we're multiplying fractions, so that's k over 1. Multiply straight across, so k times 1 is k, 1 times r squared is r squared, and very often what you can in fact do is you can just jump straight to this line here. Okay, so we've got h equals k over r squared. Now we've got the opportunity to put in some numbers. So we're told up here that r is 5 and h is 8, right? So h is 8. R is 5. Now remember, we are finding k. We want to find out what the factor is, what the constant is that's causing this inverse proportion to happen. Okay, so what's the factor that's involved. So we're trying to find out k first of all, right? So that's going to be 8 equals k over 25. Apologies about this big thing in the road again. Okay, and then 8 equals k over 25, then k equals 8 times 25, which is 200. So k is 200. Alright, so let me just go through that one more time, okay? So let's start from the very beginning. And I'll just go through it kind of quick in summary now that you've all watched it. You can rewind, of course, and look at it, the whole thing again, but I want to go through it one more time. So, variation statement says h varies inversely as the square of the radius of the base r. So I've basically written this sentence in a variation statement, okay? I've replaced the alpha, the little fish, with equals k times this fraction. Now, multiplying fractions, remember, I put the k over 1 because it's a constant, it's a number, and multiply straight across, so I get k over r squared, substitute in my numbers, and solve for k equals 200. Okay? And next we're going to see how we take this on and find the height of the cone with radius 2 centimetres. So I've got my value for k, so that's k equals 200, and I can go back to my original relationship, and now I can now see that h is equal to, so the height of the cone equals 200 over the square of the radius r. Alright, and I was asked, if we look back here, it says find the height of the cone with radius 2 centimetres. So all I'm going to do, I know r is 2 now, so that's going to be h, the height of the cone, equals 200 divided by 2 squared. So that's 200 divided by 4, which just gives us 50 centimetres. So the height of the cone for a cone of radius 2 centimetres is going to be 50 centimetres. Okay? So as you can see, once you've found k, it's really easy just by using substitution to figure out the question that comes after that, but the difficult part is probably here. Okay? So just make sure that you go over that and you kind of understand what's going on. Right? I'm not going to make any, illusions about this. This is quite difficult stuff, alright? So make sure you're getting your head around this. Rewind me if you need to and answer the quiz down there. Okay, see you tomorrow.